Welcome to the Akbar Academy podcast, where we dive deep into the science behind everyday wonders, and today we're tackling something that seems simple but really isn't. Measurement.
You'd think it's just about reading a ruler or checking a clock, right? But even NASA lost a spacecraft because of a basic measurement error.
Hundreds of millions of dollars gone. That's how powerful one small mistake can be. Measurement isn't just a school subject. It's the foundation of every precise system we rely on.
Measurement errors cascade. A tiny slip-up early on can snowball into a disaster, especially in things like space travel or advanced engineering.
What about something like parallax error? Most people don't realize how common that is.
Parallax happens when you read a scale from an angle. You're not seeing what someone else might see from straight on. It's like your eyes are lying to you.
But here's something even cooler. In high-precision labs, they factor in temperature changes of metal rulers. A shift of just 1 degree can change the reading. That's how detailed it gets.
But how do they measure something super tiny, like the thickness of one sheet of paper?
Simple but clever. They stack 50 sheets, measure the whole thing, and divide by 50. It's a great example of how science handles the small stuff smartly.
But what about measuring time? That's got to be easier than liquids or metals.
You think so, but when you're using a stopwatch, your own reaction time becomes a big source of error. A 0.2 to 0.3 second delay every time you start or stop can throw off your result.
Again, science has a workaround?
Exactly. Instead of timing one pendulum swing, they time 10 or 20 and divide. Same trick as with the paper stack, just applied to time instead of space.
It's amazing how these tiny fixes scale up to massive experiments.
In the Large Hadron Collider, they measure particle positions so precisely, they even factor in the gravitational pull of the moon.
And it gets weirder in quantum physics. There's something called the observer effect. Just measuring something can actually change the result. That challenges everything we think we know about reality.
Now we're getting deep. Measurement isn't just about numbers. It's about understanding how we interact with the world.
That's why they use significant figures, to show how precise a number needs to be. Going overboard can be just as bad as being vague.
The key is knowing when precision matters and when it doesn't.
And here's the most important takeaway. Every measurement has uncertainty. Good science means understanding that uncertainty and working with it.
That's such a perfect way to wrap this up. Measurement isn't about perfection, it's about honesty and clarity.
Understanding measurement helps you get it right, or at least know when you're off.